So let's look at a different use case now that will highlight the important difference between the higher two isolation levels, which are repeatable read and serializable. So I've reset the database and I've reset my sessions, so we should be back to the default isolation level, which is repeatable read. Okay, so the use case now is, let's say we want to only allow one row in a table, but two different transactions might be trying to insert a row into the table. So what they would need to do is select the count first, see if the count is 0, and if it's okay to insert, and then go ahead and do it. So each transaction would do something like select count star from A. If it's 0, then they can go ahead and do their insert. So, imagine this is done in software where you do the select first and then you do like a C# if and then you do an insert. And this is just a very simple demo just to highlight the difference. So let's see what can happen if two transactions are trying to do this. So we will start a transaction over here, start one over here. So now let's say the first session does its select count from A, and sees that there are 0 rows, so it does its if check and assumes that it's okay to go ahead and do the insert. So we will insert into A values, I don't know, a 1. Okay, now this one does its select count star from A, sees somewhat incorrectly that there are 0 rows, so it thinks that it's okay to go ahead and do the insert. Insert into A values, and we'll insert a different value. So the problem is not going to be a primary key violation. That's fine, but what we're trying to prevent is just any 2 rows from being inserted. Okay, so it says, okay, now both of them are going to try to commit, as they should, and both of them are able to commit, and we end up with 2 rows in the table, which is too many. So the thing we were trying to prevent is more than 1 row in the table, and a repeatable read transaction was not able to do that because by the time this one selected its count, it had not been updated yet, so it saw an old value for count. Now let's try it with serializable isolation level. So I think I've got up here somewhere. Yes, so let's set the isolation level to serializable. And while we're at it, let's reset the table. So delete from A, just delete everything. And then let's set the other session to serializable. Okay, now let's go through kind of the same sequence. So let's start a transaction over here, start a transaction over here. Select count star from A. Okay, the count is 0, so I'll do my if check, and I assume now that it is okay to go ahead and insert. Insert into A, values 1. Okay, now if this one does its select count star from A, it stalls. It's not going to get the incorrect count, it's going to wait. So this one will eventually go and try to commit. It will successfully commit, and now this session sees that we have a count of 1, so it would say, okay, I cannot insert my row, somebody else already has, so we can now, at this point, we could roll back. And we would just decide to do that in software. So this has protected against 2 transactions in being able to insert 2 rows when we only want 1 allowed. Let's see what happens, though, if the events happen in a slightly different order. So let me reset everything. Okay, so we're back to the initial state. And let's try the same thing, but let's pretend that the operations happened in a different order. So let's start both transactions again. Okay, so what we did last time was this one got to select its count and saw that there were 0 things, and then it proceeded and tried to do its insert. So instead of letting that one go ahead with the insert, what if this one then did its select? So it's still allowed to proceed, and so now it looks like we might have a problem. We have both of these sessions think that there are 0 things in the database, so both of them are going to try to proceed with their insert. So if this one does try to then move on with its insert, as it would, insert into A, values 1, now the insert is blocked because somebody else has selected from that would affect the insert that this other transaction is trying to do. They've selected from the same table. So what's going to happen now is this other transaction is going to try to proceed with its insert with a different value, and let's see what happens. So the system automatically detects that that would have been deadlock, and so it automatically rolls back one of the transactions, and this one got to finish. So if we select count star from A, there is one thing in it, and this one's transaction was automatically rolled back. If it happened in a slightly different order and the insert happened in the other transaction first, then the system would have arbitrated the deadlock in a different way, but either way, only one of them would have been able to finish the transaction, and no matter what, one of them will get rolled back when it detects the deadlock.